So how do we calculate risk in a case control study? So we talked about relative risk before as our, a very good measure of the association between a exposure and an outcome. And we remember that relative risk is the incidence in the exposed over the incidence in the unexposed. However, in a case control study, we don't have incidence. We have the likelihood of the exposure, the proportion of individuals with the disease who have the exposure, and the proportion of the people without the disease, the controls, who have the exposure. So what we have to do to calculate risk in a case control study, since we can't use relative risk, is we calculate the odds ratio. So the odds ratio is a comparison of the odds of exposure in the cases to the odds of exposure in the controls. And so when we're looking at the outcomes of a case control study, our question is, how much higher is the odds of exposure in the cases than in the controls? And so if the odds of exposure is higher in the cases, then that suggests that there's a relationship between the exposure and the disease. So let's look a little more closely at how to calculate the odds ratio. So over here, we can see that we've got our cases. So as always, we start the case control study with our cases, and then we measure the exposure in the cases. So we divide the cases into those who are exposed and those who are not exposed. And then we take our matched control group that we've created, and we do the same there. So we separate the controls into those who are exposed versus unexposed. So over here we can see our traditional 2x2 table. We can still use this 2x2 table to calculate the odds ratio, and here are the cells of the table. They're the same cells that we always see. And how do we fill out those cells in the case of a case control study? Well, of course it's the same as before. So we look at the cases who are exposed, and that's the number that goes into the first cell. So that's over here. And then the second cell is the controls, the people without the disease who were exposed. And so that is down here. And then cell C is people with the disease who were not exposed, and that's these people. And then D is the people without the disease who were not exposed. Okay, so to calculate the odds ratio, what we're going to do is first calculate the odds of exposure in the cases. Okay, so that's easy because we already know how to calculate odds. So that would be the number of cases with the exposure, right, which is A, over the number of cases without the exposure, which is C. Okay, so that's the odds of exposure in cases, and that's A over C. And then we calculate the odds of exposure in controls, right? So it's the number of controls with the exposure over the number of controls without the exposure, and that's B over D. So then to calculate the odds ratio, which as we said is the odds of exposure in the cases over the odds of exposure in controls, we just simply take those odds. So we take the odds of exposure in cases, A over C, and then that's all over B over D, and then that ends up being AD over BC. Okay, and so that is the odds ratio. So another way of looking at it, or calculating it, you can look at each of the corners. So you multiply A by D, and then that is over B times C. Okay, so that's a really quick, easy way to remember how to calculate the odds ratio. So like the relative risk, the odds ratio is used to determine whether an exposure is related to a disease outcome. So in particular, whether an exposure is related to the particular disease as defined by the case definition used in the study. And another use for the odds ratio is to compare the magnitude of different risk factors. So you can calculate odds ratios for different exposures in a case control study, and then the exposures that have the higher odds ratios are considered to be of a greater magnitude. In other words, they increase risk more. So if you look at multiple odds ratios for a single disease, you can sort of rank them in terms of their potency in causing the outcome. So how to interpret the odds ratio. So just like the relative risk, if the odds ratio is 1, that means that the odds of exposure in the cases and the controls are the same, which implies that the exposure does not affect the odds of the disease. If the odds ratio is greater than 1, that means that the exposure is associated with a higher odds of disease, and in that case, the exposure is a risk factor for the disease. If the odds ratio is less than 1, that means the exposure is associated with lower odds of disease. And in that case, the exposure can be considered a protective factor. So it's important to remember that the exposures can be either positive or negative. So negative exposures increase risk of disease, but there are also exposures that protect people from disease. So that's the interpretation of the odds ratio. So it's very similar to the interpretation of relative risk. And finally, what's the relationship between the odds ratio and the relative risk? So you can calculate an odds ratio also for a cohort study, but the relationship between the odds ratio and the relative risk are that if the outcome is rare, or the disease is rare, odds ratio is a good approximation of relative risk. However, as the prevalence of the disease or outcome increases, the odds ratio begins to overestimate relative risk. So that is an overall description of the measure that you use to estimate risk in a case control study, namely odds ratio.